So this is a type of problem where we want to solve for the reaction quotient Q, and then use that to predict how the reaction will proceed, whether it would favor the forward reaction or the reverse reaction. So let's just take this one at a time. First, solve for the reaction quotient. The reaction quotient equation is actually the same as the KEQ equation, and roughly speaking, that's going to be the product of the products over the product of the reactants. When I say product of the products, I mean like product times product, reactant times reactant. Let's write this out first. So products over reactants. Now, in our products, we have iron and H2O. However, for KEQ or Q, you only use gaseous or aqueous solutions. You don't use solids or liquids. You ignore them. So in our case, we're going to ignore this for the sake of calculation. That only leaves us with H2O in the numerator, and then you actually raise it to an exponent, which is just the coefficient of 3. Same thing with the reactants. You have just H2, which is a gas, and it has a coefficient of 3. So that is also raised to the third power, and roughly that will give you 1.8. And this is a unitless value. That solves for the first part of the question. To figure out which direction the reaction will proceed, then you compare the Q with the KEQ. What does that mean? Well, really, you're just seeing which one's bigger, or if they're equal. So if Q, in our case, is 1.8, that means it's greater than the KEQ, which is 0.064. Again, Q is greater than KEQ. That actually means we have more products than what the equilibrium would have, because notice that products is the numerator of Q, so there's a direct relationship with Q being large, meaning more products, or lower Q means less products. This means we have more products. So then, that leads us to our final bit. We see that there's that imbalance, so we use Le Chatelier's principle. Now, Le Chatelier's principle is like a seesaw act. You see where there's a change, and then you try to move the reaction in a way that compensates for that. So in our case, if we have more products, we want to balance it out on the other side as well. So to produce more reactants, the reaction favors the reverse reaction. And that answers the second part of our question.